right, we're going to look at writing equations. So most of these are going to be two-step equations. So we're looking for two operations on one side equaling to our overall total, or the overall thing that the word problem is revolving around. So make sure you looked at the hints, the keywords on the previous slides, and using those. First thing you need to remember is you've got to have an equal sign. We've got to always revolve around an equal sign with an equation. One side is going to be your total, their main focus. The other side is everything that we would do to make up that. Please remember, you can't combine, add, subtract, multiply, divide, bring together, do any process before you put in the equation. That should all happen within the steps of your equation. So you need to read through the problem first, look for those keywords, look for those important pieces that we need to have in our equation. And also, for it to be an equation, there has to be a variable somewhere in your answer. So we're going to read through and kind of underline and look for those key things. So Zach has 6 shirts. This is, so is means equals, 4 less than, twice, which tells me an operation and a number, the number of shirts in that Bill has. So 6 is my overall total. This is what it encompasses or revolves around. So 6 is going to go by itself on one side. Everything else is going to go up on the other side to how we got to the fact that Zach has these 6 shirts. So we're looking at 4 less than. Less than means subtraction, but it means subtraction afterwards. So I got to know what I'm talking about and then take 4 off of that. Twice a number is telling me that I have 2 times something, and we're looking at 2 times the number of shirts. The number of shirts is what we don't know. It's asked us to use the variable n, so I need to use that. So then I'm going to put these pieces together. So 2 in twice however many shirts, less than 4, so minus 4. This does not mean the same thing and would not be a correct answer. The order of subtraction matters, and if I'm doing less than, it's after whatever that total is. So this would be my equation. All right, let's look at another one. So here we have 8 more than the quotient of a number y and -3 is -24. So again, I've looked for my key numbers or variable, and then my key words that tell me an operation or a situation that I need to deal with. So we know we have 8 more than means we're adding. Quotient is division. We're adding 8, so it's on top of whatever it is, add 8. Quotient's division, we're looking at dividing y and -3. Is means equal, so everything revolves around this -24. So then I have y divided by -3 plus 8 equals 24. All right, let's look at the next one. So Jeremy has 13 baseball cards. So 13 baseball cards is the total that we're looking at, which is, so this 13 is 7 more than 1/5 the number m that Michael has. We know 13 is our total, so it's by itself on one side. Everything else is going to make up the other side. So 7 more than means we're going to add 7. We're looking at 1/5 the number m. So that's our variable, our unknown. 1/5 of this, or 1/5 the number, is got a hidden operation of the multiplication there. So we have 1/5 m plus 7. It helps to look at those keywords, find, underline, and circle what you've got to incorporate in the problem, and then sometimes it helps to go back and check. So I've got my 13, I've got my 7, I've got my 1/5, I added, I multiplied, and I have my variable, so I know I have all those pieces within my equation. All right, sometimes the problems, not everything's going to be spelled out for you within the pieces, and so you have to think a little bit more about them when you're reading that problem. So here we're looking at Juan's father was 29 years old when Juan was born. This year, the sum of their ages is 53. So I know that I'm looking at everything is revolving around that sum total of 53. Sum tells me to add, so I know I'm adding two pieces, but nowhere do I have a variable, and I only have 29, so what do I do with those pieces? Well, what we know is it's the sum of their ages. So I have Juan and I have his father. Those are the two pieces that I'm looking at in order to get my total of 53. So Juan, we don't know his age, so it would just be X. Juan's father, on the other hand, is 29 when he was born. So it would be whatever Juan age is plus 29 would make up his father. So this would be my entire equation. Yes, I have two variables. They both stand for Juan's age. But to make up his father, I had to take his age plus the 29 to find what his age was when he was born at that time. So it wasn't just the one piece. All right, and the last one. So here Logan collected pledges for the charity walkathon. He will receive total contributions of $65.50 plus, so on top of that, he will receive $21.75 for every mile that he walks. Well, we don't know how many miles that he's going to walk, so this would be my unknown. How many miles will he need to walk to raise $370? So the total that we're looking for is $370, so it's going to go by itself on one side. Then we have the rest of this. So we have the one-time amount that he's going to get of $65.50 plus he's going to get the $21.75 per mile. So that would be times however many miles he works or walks. So all of this, realize we have equal sign, variable. One number alone on one side, everything else totaling on the other side. Nowhere did we combine anything first in order to get our answers. So make sure you're putting everything in the equation. Everything would be solved off the equation.